Hello, and welcome to SHriMP Views. SHriMP is an interactive environment for information visualization and navigation. SHriMP Views stands for Simple, Hierarchical, Multiple Perspective Views. SHriMP is a prototyping environment that integrates various information visualization techniques for exploring different kinds of hierarchically structured information. The main motivation to use SHriMP is to improve the use of limited screen area. SHriMP allows a graphical view of an information space to become an interface to a textual world. For navigation, SHriMP uses embedded hypertext links to facilitate browsing between text and graphics. SHriMP is information independent and can visualize any hierarchically structured information that has concepts and relationships. Initially, SHriMP was designed for software visualization, but has since been applied successfully to knowledge management and flow visualization environments. Software visualization was the initial focus because many existing software visualization tools were not being adopted by industry, and we wanted to know why. 3 issues with traditional programs emerged. First, as large programs naturally generate large graphs, attempts to visualize these large graphs on small computer screens were difficult. SHriMP addresses this problem by allowing the user to filter out unwanted relationships and selectively abstract information that is not of interest. Secondly, graphical visualizations made with existing software were oftentimes too far removed from the system and documentation to be useful. SHriMP provides direct access to the source code's documentation, complete with navigational links for easy cross-referencing. Finally, many of the tools used multiple windows to display visualization information, which confused users and added the extra burden of window management. All of SHriMP's visualizations are contained within one window. Nested interchangeable views allow for quick transitions between package nodes, class nodes, and others. You can open a package node to see its children, and then zoom into these and see their children as a graphical visualization, documentation, or source code. As mentioned previously, SHriMP can visualize any type of hierarchically structured information. For Java programs, possible sources of information include metrics, documentation, source code, architecture, requirements, and version control and management. Let's see how SHriMP Views works. The program shown here is a GXL to RSF parser written in Java. Once the program loads, we see a package and a class. These are the highest level concepts that were extracted by the Java parser. If we open up this package, we see that this package contains 2 packages and a class. Already we're getting some high-level information, such as the size of the program, the number of packages, and the number of classes. We can zoom in on one of these nodes and try to get more information. As we mouse over the nodes, node labels appear with the class name. This becomes important contextual information that we can use to help us build a mental model. We can also examine different relationship types. I'm going to look at the inheritance relationship, where one class is inherited from another. We can also do a tree layout of the inheritance graph and get an overview of the kinds of inheritance in this program. This is actually an upside-down inheritance view, and we can see that this class down here, UML item, is being inherited from these other classes. We can perform other kinds of layouts as well. This tree graph is a Sugiyama layout, but there are also grid layouts and spring layouts. As we can see using this spring layout, UML item is one of the central classes in this package, because the other classes are subclasses of it. We can open all the nodes in the graph to get a feeling for what's in each of these classes, such as methods, parameters, and variables. Again, we can look more closely at the relationships within the program. We can look at the type dependencies between different classes. These arcs represent the implements relationship, when a class implements an interface. These arcs are method references. We can see from this graph that there are a lot of references to methods within the classes. We can also look at variable references. There are some variable references going on between classes that might indicate that some variables aren't as well encapsulated as they should be. Instead of looking at this graphical world, we can also look directly at the source code or the Java doc. Using nested interchangeable views, we can examine the source code and use the embedded hyperlinks to navigate between nodes. We can navigate this way within the Java doc documentation as well. Using the control box, we can navigate forward and backward along these hyperlinks. SHriMP also includes other useful tools. The search function allows us to search the source code for keywords or phrases. For example, let's search for the main function of this program. We enter the text main as the search string. SHriMP returns matching results. We can double-click on the result to navigate to the main function within the program. To keep us oriented within the program, the navigation view is also a useful tool. It gives us a high-level view of the program and where the current view is focused within the program. As we navigate through the graph, the navigation view is updated, providing us with orienting information. We can also navigate directly within the navigation view. Finally, the film strip tool is useful for saving a set of views according to a particular perspective. This film strip can be saved to disk, and individual views can be reloaded by double-clicking on its thumbnail. SHriMP has been implemented using Java Beans. As such, it is possible to integrate SHriMP with any other application that uses Bean components. Thus far, SHriMP has been successfully integrated with the Protégé knowledge management system being developed at Stanford University. The amalgamation of SHriMP and Protégé is known as jambalaya. By itself, Protégé does not provide any graphical visualization of its knowledge bases. Jambalaya provides this graphical visualization and an alternative method of navigation by adding a jambalaya pane to the Protégé interface. As you have seen, SHriMP allows the user to customize and interact with the information exploration environment in many ways. Any relationship can be the nesting relationship, and nodes have multiple representations and behaviors. The composable layout algorithms, along with manual layouts, are also customizable. Users can browse and abstract information at different levels of detail, save views for future reference, filter relationships to reduce cognitive overhead, and search the source code, all using the same environment. If you have any questions or comments about SHriMP, please feel free to contact us via email. To download your own copy of SHriMP, please visit our website at www.shrimpviews.com.